In this short video, I'm going to explain you how to plan your workovers and surveillance with an example of a synthetic asset. So first let's introduce the asset. So here's the geology. The simple dome structure, but here on the left we can see several folds, and some of them might be sealing, some of them might be transparent, we don't know yet. So here's the cross-section on oil saturation built by the previous team. From what we can see here is we have several units, and the units have different oil-water contacts. And another thing is that the bottom unit has a strong bottom water drive. Okay, next is the cross-section on permeability, and I think that the interesting thing here is in the northern part of the reservoir across, let's see, 20, 18, 24, right here, in the unit A3, the bottom part has a very high permeability. And it actually means that inside this cross-section, while we try to run the water flood, the water will pass very fast through this bottom part of the reservoir. And in some wells it could be a problem. So if we see an early water breakthrough, we know what to fix and which layer to shut in an injecting well. Here we can see the production maps, the current production, the cumulative production. So we see that the southern part has more initial reserves, but it produces very slow. So it actually means, one of the things which it means is that we still have more reserves in the southern part. Okay, also we do see that the cumulative injection and the current injection is higher than the current production in most of the wells. And that also raises some concerns about, do we really inject this amount of water into the reservoir? So here we can see that we have a very high cumulative injection in a couple of wells, but it's still a very good question if this injection is going to the right layer, because from what we can see from the pressure monitoring, the pressure is lower than the initial one. So here we can see the distribution of pressure taken by pressure buildups in the wells, and we can see that the pressure distribution shows a very low pressure. Again, the initial pressure is 125, and right now even in an injector well with the highest pressure we only have 110. It means that the field is severely depleted and we need to repressurize. So that actually means that we need to focus on the activities in the injection wells. So if we were to study the injectivity or productivity index, we would see that we do have several wells very suspicious with a very high productivity index. We, especially here in the southern part, we have two injectors with a very high productivity index, 10, 22, and a producer 12, also with a very high productivity. And that, in fact, could mean a channel, a crossflow, which could be seen on the cased hole logging plot, which we need to do in these wells first. So here's an example how it could look. So here we can see a cooling in injector number 10 in front of the top layer A1, which is not perforated. So this reservoir A1 actually stays cool even if we shut the well, which means that it has been taking water, which should not be the case, and we need to fix it right now. And then actually, in order to increase the injectivity and prevent a new channel from occurring, we should rather consider stimulating this well or even performing an induced fracturing job. Next, thief production on well number 12. So here on the right you can see how it actually happens. So we produce with the bottom hole pressure, then we optimize the well, we lower the bottom hole pressure, the rate increases, then we do it again, and at some point we increase the pressure gradient over the critical pressure gradient, and the cement breaks between the productive layer and the non-productive water saturated layer, and that gets us a channel. So we can see that the productivity is higher now, and we have additional water production. So even on the historical plot, in most cases it would be quite easy to see, because we all know that the water does not come just by the snap. The water comes slowly, and we see a sudden increase in production rate, liquid, water, and sometimes pressure. That would mean that we got ourselves a new channel, which of course needs to be fixed. Then here is how we can see the situation where the injection wells create an induced fracture. So sometimes when you press too hard and the pressure is too high, the reservoir would break, the formation will break, and you will get a fracture. So here in the PetroCup that also can happen, and here is you can see the result. So here in the well 22, you remember it had also had a high injectivity index. If we run a build-up, you can see the typical behavior of a fracture. So a slope of 0.5, which is indicating the linear flow to the fracture. Unfortunately, the induced fracture cannot be fixed. But what we can do, at least, is to reduce the amount of water which we inject here into the fracture and redistribute it to the wells where this water would be more useful. Another thing is the study of the skin, because sometimes if you can see that, judging by the open hole log, the productivity of the well should be more or less the same with its neighbors, but somehow the productivity is lower. So what we can do is we can run the pressure build-up and sometimes even qualitatively see if the skin is low or, such as in this case, quite high. So here we can see that the pressure derivative in the radial flow, during the radial flow, is quite far from the DP curve, and it actually means that we do have a very high and positive skin. So skin of +6 means that we have a potential of increasing the productivity index by, well, approximately 2. So we can have twice as productive well if we stimulate it. Or we can actually perform an hydraulic fracturing job and make it even more productive. Then the drilling strategy. So again, according to the analysis of the initial reserves, the analysis of the production, cumulative production, we can understand that most of the reserves still sits in the southern part of the reservoir. And here we can place the wells. Actually, we can make it differently, and some team would use vertical wells, some would use horizontals, some would use horizontals with hydraulic fracturing, but I think that the picture which we see on the left is the reference case scenario of drilling in the southern part. So this particular well configuration will provide you the best development scenario. And another important thing is that when you drill, it is a unique opportunity for you to build a pressure profile across different reservoirs. Because if you have a layered cake, you have several deposits, and you drill a well which is actually penetrating several reservoirs at once you drill and complete a well, you would not be able to understand the individual pressure in different layers, and that is actually a critical information. For example, if you drill a vertical well, you need to sample the pressure in your water-saturated thief layers, such as A and C on this picture, because this information will give you the idea on which bottom hole pressure you should set in your producers and injectant, not to get a channel. Another thing is that individual pressure information in the reservoirs will give you the idea of how good is your water flood, and should you intensify some layers or even shut some layers to get better conformance in your water flood. So that is how you develop a strategy of workovers and surveillance. Thank you very much.